we're going to talk about linear algebra. And I'll just start with a few words actually that we'll catch up later. So, ideally, in linear algebra, we already talked about scalars. If you already are aware of scalars, it's how you would move well, the x and the y's, but in linear algebra, they would actually call the ones at the x coordination, x here, these parts of uh, the line, x line here, I just call it the x line, and they would call it the I hat. So this, a normal I hat would just be this one, it's one, and the one that they would do on y is that they would do it in j hat. It's very important, when you're starting out, I think, that you have to start with thinking of it really as scalars, and you just like, for example, if you give it 2 I hat, it's gonna be double the size of it, so it's gonna be like 2 part of the x, there's gonna be 2, and so forth. So if you just adjust the coefficient of it, it will move it. Now, there's another concept that we're going to talk about. It is the span. Ideally, a span is just something that tells you what space you can go through. And why is it like that? Well, it's very, very simple. Uh, so, made a new line again. If your span can move like this, you have two of these and it goes like that, your span can go anywhere because one goes through the x coordination and the other one y coordinate. So it can basically move around. That is what they would call linear independent, because it allows you to have as much span everywhere. You can basically put it anywhere you want. But as long as there's an independent version of it, there's also dependent. So what would a dependent look like? Well, a dependent would actually be that basing it is that you can actually simplify it, So for example, you have two vectors and these vectors are at the same line. So the only span that you can do is that you are only doing it at one line, which, your span only moves as a line. But in terms, we could also do this at 3D, which is interesting actually. If we were to turn this into vectors of x and y, or I hat and j hat, you could actually think of it as a piece of paper, because we're only focusing on x and y. But if we add another one that is, linear independent, then you are basically moving a piece of that paper up and down. Like when you're going through a 3D program, you have maybe a cube and you have your x, y, and z's. So, you're putting your scalar, so you move your x first, and then maybe you wanted to move it to the right with y. Then your final part is Well, going to 3D, which you want to move it up, that is the z, x, y, and z. But these are most of the sense that I think some of the concepts that you'll find in linear algebra. So, yeah. But another thing is that you could also be linear independent if all of a sudden that your other vector is just the same point. So, for example, you're going back to the same vector. Well, you wouldn't need it anymore. You know, if you don't really need, it's only linear independent if you think that you know that you don't really need to move it. You don't really need to adjust it. You don't really need to, because you can basically just show it in a much more simpler way. Much more simpler way. So, for example, the idea that I'm talking about, the line, that is also linear independent, and you can't basically move it around. So, you could only use, you could, in terms, you could just use one vector to basically show the span. So that is linear dependent. And linear independent requires you, is impossible without the other vectors. Another concept that when you're doing linear algebra, I think there's just certain preference, but it's also good to talk about it. When you're focusing on only one vector, you want to think of it as arrows. But when you're thinking about a lot of arrows, it's going to get everywhere and basically you're not going to be able to see it. So, a good thumb to think about is that each of these sort of arrows can be turned into points. So, if it was only singular, I think, you know, you could give more clarity when you show it in a line. But when you're doing it in multiple vectors, it would be better if you just do it with a